Hey folks, so today we will talk about artificial intelligence, agent memories, and graphs. And so the hybrid RAGs, graph RAG is everywhere. Microsoft made actually the framework and researches, and every day we hear that actually graphs help us to build a better memory for the artificial intelligence. And it's true, we're using the graphs in my kin also. And so it's the crucial part. And let's go a bit deeper and understand what it's about. And we all know that graph actually is the mathematical structure that have the set of nodes and set of edges that are pairwise sets of nodes. Yeah, so that the edge connects to nodes, and actually it's how the computer science actually describe the graphs, and we have different kind of graphs, directed one, undirected, and all other things, and it's already quite complex, and we have a lot of challenges around of the classical directed graphs and a lot of mathematical theories of the graph models and all those things, so it's already quite complex. But when we're talking about the memory, we could not consume graph as is because it's still not so useful. It's more useful to understand what the nodes and edges mean. So we working with the knowledge graphs, and how to turn the graph to the knowledge graph. It's quite simple. That you encode in the nodes some real entities from the piece of knowledge, and ages became the relation between the entities. So you describe how the real things connected to each other. And for this, actually, we need to have the abilities, because the most simple one is the labeled graph, that you just have the string, and we all know this revolution of the knowledge graphs that Google started, that instead of the strings, we use the things. So we bring the full-scale entities to the knowledge graph. And here, one of the extensions of the classical mathematical graphs arrived, that we try to encode the full-scale entities and bring some properties. And here some wild things begin, because right now we have the army that working with the RDF and resource framework and allow us to model the graphs in RDF triples that actually describe how the resources connected to each other. And another big army actually work with the labeled property graphs. And what they do, they compress actually the resource definition framework graphs, then triples, to something more condensed. That instead of having the quite big graph that try to capture different properties, they compress the graph back, that you have one single node, and inside the single node you have the complex entity that describe actually this node. It's keep the graph compact, and it's easy to operate, and it's easy to understand even for the developers how the property graph works, but we lose the ability to create complex structural connections between the different properties of the object. So you could not connect the age of node with the date of birth of the node, and encode some actually properties between this. But it's not my topic. Actually, I don't want to go deeper between the labeled and property graphs, because it deserves their own video. What I want to talk about, it's how the graphs actually serve the need of the artificial intelligence and agent memory. Because what we faced currently in our project, that simple knowledge graph or simple personal knowledge graph is not enough. Because in an agent, you capture some experiences, you capture some events, you capture something complex that produce quite complex directed graphs. And I had an article on the Medium, and I meet a lot of people on different resources that working with the knowledge graphs, that say that the triple did describe you the relation between the object and subject is not enough. it's not enough because they not capture some another complex information like temporal relations, different context, emotional context, and all other things. And it's not how our human memory work. Yeah, so it's not just plain made map that connect to entities. You usually have a lot of context around the entity. You have a lot of context around the relation, where this relation appear in which time, and even time itself actually is quite challenging to model in a knowledge graphs. And I wrote tons of articles on my Medium how to encode time in a knowledge graph, how we have the time event knowledge graphs and all those things. And it's a lot of strategies how to bring time, but still, if we solve the time challenge, then we will face another challenge that uh, we remember our information in some kind of buckets of the facts that relate to each other. And these buckets of the facts, actually, it's a complex graphs and subgraphs. So it's the structure that not fitting well to the plain graphs. And we have a need to create something more complex. And these more complex structures actually exist in mathematics already, and it is the subject of research for a long time. For example, we have the hypergraphs, and how the hypergraph different from the classical graph, that hypergraph have ability to have the hyper edge, and hyper edge actually connect the sets of nodes. So your edge could contain a lot of nodes inside. And you could divide the nodes on the input and output nodes to simulate the direction in a hypergraph. And the hypergraphs solve a lot of challenges, because right now we could capture much complex relations in a graph. And it's already complex enough. And it could be the answer, for example, for the this time components, because right now you could create the event or time as an edge that will connect a lot of nodes, and then we encode this complex relation and so on. But my challenge was the hypergraph, that I was quite keen to work with the nodes as a set of other nodes, or make nodes contain the subgraphs, and it's not possible in a hypergraph, because you could not reference actually the edge as a node. So only edge could contain the set of nodes. And for me, it was the challenge, because then I invent my own data structure, and I was quite happy about it because I made the innovation, right? But at some point I discover that in a mathematics and the graph theory, we have the data structure that actually help us to do it so. And this data structure actually is the metagraph. And metagraph is the further abstraction of the graphs, but quite complex one. And it's have a lot of properties that practically unreal to visualize and practically unreal to model in a relational databases. But the concept is quite simple. First of all, the nodes could contain the subgraphs. So the node could be a container for other nodes. And that's what we want. We want this graph of graphs. Another quite tricky thing, that right now your edge is the same as a hypergraph edge, could connect the sets of nodes. And it's clear that you have the input and output set of nodes, and it's super easy. It's practically the same structure as our regular edge, but right now it's contain the sets and work with the sets, and it's super simple. So in this point, it's super cool. We have the graph of graph, we have the edges that could connect the individual nodes, or could connect the set of nodes, and it's already good enough. But that's not where the craziness of the metagraphs actually stops, because the biggest thing in a metagraph, that the edge itself could contain the subgraphs. And so the edge itself could capture the additional knowledge that could be represented as a subgraph. And it's mind-blowing, because it solves a lot of things, how the artificial intelligence agents could capture the context, the temporal one, the emotional one, and so on. So the age itself contain the two sets of nodes that we connect these sets, and contain the subgraph that maybe could capture some additional context. So the age actually, it's the connection of the three types of the node sets. It's already really complex and really crazy. But the most craziest thing about the metagraphs that you could use the age as a node and vice versa. So you could change the roles depending on the context to create extremely complex hierarchical links in a graph. So we could have the age, or we could form the set of ages that create the node and then create the reference. And it's more like how the human memory works like. So it's quite close to the structures that we believe we have in our brains. If you know a bit of the categorical theory from the mathematics, you know that your relations are functions, but these functions form the category itself. So it's the representation of such type of the relations. So the metagraphs allow us to give the artificial intelligence agent the structure that mimic really the possibility to encode the multimodal, multi-context, multi-temporal context information. And it's mind-blowing. But the challenge of the metagraphs that when I try to model them on the piece of paper, for me it was the challenge to put it to the relational model. And another challenge of the metagraphs that we as a humans could not easily visualize them, because if we have the hypergraph, we could model it as a Venn diagram of the sets and intersection of the sets, but even this could be quite complex already. But for metagraph, I don't have the nice representation. And what I'm worried about, that the metagraphs are so complex that maybe it will be the complex concept not only for the human but for the LLMs too. And maybe to make the metagraphs work in a proper way, we need the special models that actually do the machine learning on the metagraphs. And actually, it's the reality. I found a couple of papers that describe some biology and biochemistry problems that are solved as a machine learning on the metagraphs. But when I try to Google more and understand the metagraphs better, I found a couple of papers that I need to pay to get the access to it. And I found only one book that quite good. It describes some mathematical challenges and describe how the metagraphs could be used in a business space and project management space. But that's it. So I have a feeling that we need to invest more to the metagraph research. We need to invest more to machine learning in the metagraphs. Or maybe we could simplify the metagraphs and limit ourselves to the concept of the graph of graphs that could give us a lot of benefits. I will talk about this graph of graphs and modeling of the complex memory maybe in my next videos. If you're keen to hear more, let me know, comment it on this video, subscribe to our channels, share it with your friends, share it inside your team. If you do something in a space of the AI agents, let me know. I'm quite keen to talk about this too. So that's all that I was keen to share with you. I was keen to present you the idea of the meta and hypergraphs and how we could use it for the artificial intelligence challenges that are more in a term of complex memories, temporal aware memories, and multimodal and multilingual representation of the knowledge. So that's it. Thank you and see you next time.